This challenge, we're going to look at memory forensics, and we're going to have a play around with a tool called Volatility. So the scenario we've been given is easy hack the box challenge called RogueOne, and this is simply saying there's been some C2 communications. The user hasn't been able to identify what's gone on, so it took a memory dump, and it's our job to go in and investigate that. So we're going to go do that now. So ultimately, Volatility version 2.6, which is the one here on Windows, didn't work. So instead I moved over to Linux and switched to Volatility version 3. So what I've done at the minute is I've run a command. I'll press up arrow so you can see it at the bottom here. Called it using Python 3, called the location vol.py, and then I called the memory file, and then I ran windows.pstree, which is one of the plugins for this. This gave me this hideous output. It might have been better to push this out into a file, but it is what it is. As soon as this loaded, I could see at the bottom there was something of interest down here, because we have this SVC host, which is running from the user's downloads folder. So if you see here, it tells you the process ID, parent process ID, the name of the process, and then as you move further along, got the location where this was stored. So we've got the user's Simon Stark downloads SVC host, and that's not normal. So the 6812 is what ended up being the process ID of the malicious process. And then underneath that, we've got the SOC team believes that it was spawned another process. Now, because I ran the PS tree, this is actually showing us the process tree. So we go immediately from our SVC host right here. Directly beneath it, we can see this command.exe as well. Because of the extra asterisks on here, see this one has 3 asterisks, this one has 4. This is in it's a child process, and this is giving us 4364. Again, I've entered into here and was correct. And this really speaks to knowing what normal is so that you can find evil, which is a little bit of a SANS tagline. One of their posters talks about it. But the idea of SVC host running from anywhere other than the Windows System 32 folder means it's just not right. So as soon as I saw SVC host in the downloads folder, immediately knew there was something wrong. So either the author had put in a huge red herring, which would have been a little shit thing to do, or that was the malware, and it was the malware. So the next question wants us to dump the file and then get the MD5 hash from it. That is the only way to get the hash of this file. So what we need to do is dump the process. So we got the -f for the .mem file. The output is quite simply // because I'm already in the RogueOne folder. We're calling the windows.dump files. I'm giving it a process ID of 6812, which we've already decided was for the SVC host. So this is what I am dumping right now. Well, that was strange. I literally typed the same thing in again, and it seems to be working this time. Wasn't working the first time. First time I did this, I got an error saying that capstone could not be found. So after a little bit of Googling, figured out that's just simple as running sudo pip3 install capstone. Did that, and now it worked quite happily. So we now need to have a look. We should have things. Oh, we got a lot of things in there. Also, I want to do MD5 sum. Let's try this one. That gives us an MD5 sum of this. So there we go. We used the process ID to define exactly what we wanted Volatility to dump out for us. It wasn't as graceful and clean as it could have been, but it got us the result that we needed. So we dumped out the malware, we took the hash of it, and we dropped that in. For the next task, we need to get the IP import. So this is using one of the NetStat plugins. Now, if you're wondering how I'm getting the name of all these plugins, it's not in a fun way. So there's a list of all of our plugins. Have fun reading through those. There is a windows.netstat in there, just trust me on this one. So if we do a windows.netstat, and we'll run that. Out the output for us. Now, we could have used grep or something like that to make sure we only got the results we wanted. We could have also piped it into a file and used that to interrogate it, but as it stands, it's not too bad. There isn't too many things which are connected on here or established, which is basically saying that the connection is open. So if we look, we know that our process ID is 6812. Obviously we knew it was 6812, didn't we? Yeah. So this gives us an IP address and a port. As you can see there, foreign address, foreign port. So we copy these. We'll need to reformat them in here. So go back. Put a colon in there, make sure there's no white space at the beginning. Oh, good. Submit that. That's the next challenge done. For the next task, we're simply after a timestamp. The two things here, it says when the process was executed and C2 channel established, we're going to work on the assumption that was exactly the same time. Sometimes these processes do start and don't establish a C2 channel immediately, but it's CTF, who cares? So we've got this one here. All I've done is scroll back up to the PS tree, which we ran at the beginning, and this has given us a timestamp to use. So we'll copy that one. May have to reformat this, so slashes and colons. Should be right. No. Day, month, year. Did I just do that backwards? Yeah, I did. God forbid we keep the same format. 2022. What year was this? What year is it? 2023. I was close. And there we go. So that was just simply a formatting error. Oh well. So the next question is asking us for the offset of the malicious process. And again, we have that information right here. Let's copy that. Paste that in there. Press submit. That's the next one done. For task 7, this is quite a fun and interesting one because this is talking about OPSEC. You shouldn't be uploading unknown samples to VirusTotal just off your own back. You need to make sure that these are authorized by people to say, yes, you can do this, because it's unlikely, but it's possible the threat actor is monitoring VirusTotal to see when they've been put up there. But it's more likely, and I think the bigger risk really is information leakage. You know, if this malware is very specific to your company, you could be releasing something with your company name in it so that people know that you've been compromised, and that's not great. So anyway, we're going to use the MD5, which we picked up earlier, and then we're going to go on VirusTotal and see when this was first uploaded. So let's have a look. Now we simply do press search, drop the hash into there, rightly details. First submission, there we go. Grab that, drop that into here. Again, have to change the date format because ISO date formats are not allowed apparently. That is another one solved. So interestingly, having to use Volatility 3 made that one a hell of a lot easier, but at the same time harder because I've never used Volatility 3 before. But if you want to do any sort of memory forensics, then it's probably worth learning the new versions of Volatility because that's what's being supported and updated. And as we move into Windows 11, it may be even that Volatility 2.6 doesn't get an upgrade or plugins which work for that. They might, but it might not. Give this one a try. Try Volatility 3. And then obviously after that, subscribe to the video because, you know, someone's got bills to pay. Anyway, have fun. Catch you in the next one.